Hi all. In this video, I plan to give you an overview about the project one and explain some of the basics that you need to start with this project. But before starting, I would like to let you know that this presentation is just going to be an overview, and it's missing a lot of details. And the project guide document should always be your primary source of reference. Okay, so if you need to understand what exactly is to be implemented or what are the deliverables, you should definitely go and refer to the project guide, which is this document that I share on screen right now. This is available in Canvas, and you can access it along with the code files that were given to you for this project. All right. Apart from that, we will also go through the code. I will try to summarize some of the basics that are needed to start with this project. But again, I would like to let you guys know that if you have any doubts or questions, you should always refer to the source code. The source code is again available in Canvas under the project folder. And you should always try to understand the details of the implementation or the framework that is given to you to make sure that your project code works fine. So be aware of this. This is just going to be an overview. Okay, so let's get started. So first, let me tell you what exactly I'm going to cover in this presentation. First, we will go through the project overview, and I'll briefly explain how to connect to the server and how to set up your project so that you can run the code on the server. Then we will do a code walkthrough where I will try to go through some of the files that are relevant to this project. And yeah, that's it. So let's get started with the project overview first. Um, as you know, this project is targeting a design space exploration. So what that means, DSE is actually okay. So basically you are given a system, and the system has a set of parameters, and the system generates some kind of output. So basically the parameters control how the system behaves. So the parameter is tuning the system so that the desired output can be generated. And design space exploration is basically a process of narrowing down values of these parameters in such a way that our targeted output is achieved. Okay, so basically there may be like n different parameters for the system, and you are expected to tune all of these n parameters and try to narrow it down so that finally you achieve the best set of settings for the parameters, and that will give you the best performance. That's what that's in a rough way, that's what is design space exploration. So in this project, DSE refers to finding the best settings for a range of design parameters of a computer architecture. So you have an architecture, and you are adjusting the parameters of that architecture so that it maximizes either of the following two metrics. Okay, so first one is the performance. The performance is measured in terms of execution time. Okay, so you run a program and you measure its execution time, and somehow you want to tune the parameters of the architecture so that the total execution time stays low. The second metric is the energy delay product. So it's a more broad of a metric because it comprises of two parameters. So both energy as well as the execution time are considered here as a product. And as you know, if you try to minimize the energy delay product, basically you are targeting to minimize both energy and execution time so that you achieve a better configuration. So both of this will be a target for our design space exploration, but we will deal with them one at a time. So basically, first we will target a DSE for performance, and then as the second version of the project, we will target energy delay product as the metric for optimization. But you don't need to do anything very drastically different to implement two of these strategies. It's just the same strategy, just that what metric we are trying to optimize, we can pass it as an input to the execution file. And basically that will just switch based on your input and it just runs out. So basically you're just going to write one code for optimizing for both of these metrics. Okay, so another thing to understand is that there are two types of design space explorations. Okay, there is an exhaustive exploration where imagine you have n metrics for the system, and one way to do it is to find out um, all possible combinations of settings for all the parameters and run an exhaustive search. That is, if the number of possible solutions is large, then the DSE may explore all of them individually, and then it consumes a lot of time and it's not practical in most scenarios. So intelligent heuristic, what it tries to do is to trim down the number of design points that you plan to analyze in order to arrive at the optimal decision point. So basically, we prune down the design space to prioritize evaluation for not more than reasonable design points first. So basically, you don't have to go through all the design points or design space. You just intelligently select metric values in such a way that you reach the optimal configuration in a faster way. Okay, so now, what is design space? So the design space is a set of parameters over which the DSE exploration is going to be done. All right. So if there are like 10 parameters and if each of them have like 5 values, then your design spaces can have up to like 10 raised to 5 possible combinations. But we are not going to explore all of them. We are going to trim down the design space drastically so that you can actually run your code and finish it in time for submission, right? So in this project, we have the following group of design space to explore. So we have a set of parameters for branch predictor. Then you have cache configurations, and then we have core configurations, and then we have floating point configurations. Okay, so this is not the complete set of parameters for each of these classes. Basically, it's one of your goals to identify what parameter belongs to each of these classes, and then so basically identify what is each of those parameters. So probably there won't be any explanation given in the project guide, I believe. You can just try to find out what each of them mean on your own. That'll be a good exercise to understand the architectural parameters. So in total, in our design space, we have 18 parameters, of which 15 are independent parameters and 3 are dependent parameters. So the dependent parameters are something whose value depend on the independent parameter. So we will look at that in briefly in the upcoming slides. So basically, this is what this project is about. So we have a design space, and then we try to narrow down the settings in such a way that we optimize either for execution time or energy consumption, sorry, energy delay product, basically, right? So how do we do that? How do we try to, or before going there, let's look at what is this architecture simulator that we are using in this project. It's called Simple Scalar. So the architecture simulator is exactly a program that simulates the execution of a computer architecture. So it's a piece of code that in a way mimics an architecture. So basically, what is the advantage of using such a simulator is it allows us to modify architecture parameters in code without making any hardware changes. So basically, if you want to try out different settings for your architecture, you don't have to make a new hardware for that, right? So instead, you just use a simulator and adjust its parameters so that that simulator will behave as a modified version of the architecture. Okay, and one thing to note here is that the simple scalar is actually simulating an architecture called PISA, and it's very similar to the MIPS architecture that you have learned in the lectures. So it should not be very confusing. And also another thing is that this architectural simulator is more like a black box to us in this project, because we just give some inputs to it and we just read the output that it generates. You guys are not going to directly modify any code to change the way the architecture behaves. So so if you are interested in understanding the architecture better, you can go ahead and understand the review the code. I have given the link to the simulator in the project guide, so you can go through that to understand the architecture better. You may even want to look at the code for the simulator, but for this project we don't need to do any of that. Okay, so yeah, so uh, just a uh, overview of the architecture is sufficient to do this project. Okay, so how this simple scalar works, basically what you need to understand is that it is a black box which accepts a set of design parameters. Okay, and it also an executable or a workload as an input. So there are two sets of things that we input to the simulator: design parameters as well as the executables. And basically, the using the design parameters, the architecture will adjust itself. So basically, you can say that the cache, I'm going to use the 2 KB cache, L1 cache, and then just enter that number into the simulator, and the simulator will adjust the cache size to say like 2 KB, and then run the executable on this modified architecture. So the executable, you can think of it like your typical application, like some kind of memory operation or something like that. That is also an input to the simulator. So basically simulator just configures itself using the parameters and then run the executable on itself. And when it is running this executable, it generates a lot of system statistics. That's what we are interested in, right? Because we change something on the architecture by inputting some inputs into the simulator. The simulator has changed itself, and now it ran something on it. Now we are interested in how that changes affected the performance of the simulator, right? So to understand how the simulator performance or energy consumption changed, the simulation will output a lot of statistics, like the number of instruction simulator, maybe the execution time, what's the total time taken for executing this workload, number of cycles, clock cycles taken to complete this execution. There is a huge amount of information that is output from the simulator. We will look at that as well later. But just to understand, just to let you guys know, we are mostly interested in only the execution time, and all our computations are dependent on the execution time to complete a particular workload. All right. So this gives you an overview of what exactly is happening. Okay, so you can treat the simple scalar simulator as a black box, and you have two sets of inputs. So you have a set of workloads. So to be precise, we are using 5 benchmarks as workloads. So you can think of it as 5 different applications, and we are going to change a number of settings. Again, there are 18 settings that we are interested in changing, and we are going to, after changing these 18 settings, we will just set this parameters to certain values, 18 parameters to certain values, and then so then the simple scalar will modify itself to these parameters, and then we run this workload on this modified simulator. And once the workload execution completes, it generates the system statistics that will have informations like number of cycles or number of instructions simulated and so on and so forth. All right, so that is the workflow that we will be following. And we also have a so here I'm showing a list of design parameters that we are interested in. So I told you there are like 18 um, parameters or dimensions. We can call them as dimensions that we want to explore in this DSE. So these are the 18 dimensions that we will explore. Okay, and how do we do that exploration? We have our own. So we have proposed a heuristic. Okay, so this is also in the project guide. So so the design space dimensions can be labeled either as explored or unexplored, right? Because initially all the dimensions are unexplored, and initially then first in the first step we will set all dimensions as unexplored. Then we will choose one of these unexplored dimensions, and evaluate all possible design points by changing the values of this dimension. So basically, if you go back, let's say all of them are unexplored right now, then we pick width as the first dimension to explore. Then the width can have multiple different values. So we will run the simulator with each possible value for width and get the system statistics, like the number of cycles taken for execution. So if the values are like 2, 4, 8, 16, then we will run 2, 4, 8, and 16 settings for width. There are going to be like 4 different runs, right? So all the 4 different runs are compared against each other, and one with the least execution time, we will pick that as the best setting for width. I hope that makes sense. So that is what is explained here. So we initially mark all the dimensions as unexplored, then we pick one of the unexplored dimension and then explore all possible values for that particular dimension. And once we figure out which setting is the best setting for that particular dimension, we will fix that dimension to that value, the best setting. And then we will mark this dimension as explored, and then we will move on to the next unexplored dimension. So that is a very simple heuristic that explains what is to be done. All right, so let's go into the details of this heuristic. So how do we do the exploration? So we have 18 different dimensions given listed here, and our first goal is to formulate a dimension array using the heuristic. So initially, let's imagine there is you are formulating an array. Initially it is all empty, and you need to give value. So width corresponds to the first element, scheduling corresponds to the second element, and so on. So there are 18 different columns in this array, and you want to start somewhere, right? So in order to start somewhere, what we do is we assign a baseline configuration as our default starting configuration. Okay, so this setting of baseline configuration is already given to you in your project file, so it's already there. So I'm showing initially we start with a baseline configuration for all the values. So what this means is that width is set to 0, scheduling is set to 0, DL1 set is set to 5, and so on. All right, so this is the baseline configuration where we are going to start with. And then what we do is we pick one of the configuration. Let's imagine the case where we start with width here. So we pick width as the current dimension, and we set all the unexplored dimension to the baseline configuration value that was given to you in the project files. And now let's look at width. Width can have possibly 4 different values: 1, 2, 4, and 8. All right, so what that means is that these possible values of width have to be tried out on the simple scalar. So each possible value of width has to be tried out separately on the simple scalar machine, and each of those runs will be compared against each other, and one with the best execution time will be picked as the best setting for width. All right, so again, one thing to note here is that the value of 0 for width means that the 0th index in the possible array will be used. So a value of 0 here means that the width will be set to 1. All right, so when you formulate your dimension, when you formulate your configuration setting, you will only be dealing with indices, okay, index into the arrays of possible values for each of the dimensions. So width can have 4 possible values. So if you pick 4 as the possible value for exploration, then you are going to set 2 as the value here. So your configuration settings are only indices. It's not going to deal with direct absolute values. It's just going to be indices. So similarly, if we look at the 4th dimension, which is the DL1 set, it can have possible values, which is given here. These are the possible set of values. All right, so now you can see that 5 is the value given to the DL1 set in your configuration setting. What that means is that the 5th index will be used. So 5th index is 0, 1, 2, 3, 4, 5. The value of 1024 is the actual setting that is going to be used for DL1 set when you set this value to 5. All right, so I hope that is clear. Just to reiterate, the configuration settings are going to use indices, and the index value is dependent on the specific parameter value that is to be used, and also its position in the array of possible values. All right. Okay, so let's get to the next step. Okay, so once you iterate through all the possible values here, you will see that one of them may have a lower value for execution time. All right, so in this case, let's assume that if when the index value was 2, it would pick 4 as the width. So again, width basically means the issue width, right? So if you set the issue width to 4, it means that it can execute up to 4 instructions in parallel. All right, so that's what the width means. So basically, let's assume that 4 gives the best execution time in the scenario. If that's the case, your best setting for the configuration would be a 2, because 4 has an index value of 2 in the possible array. So it will become 2 as the so that means that once you find out 4 is the best setting for width, you will assign the index number of 4 into the configuration array, and then you mark this dimension as done, right? Because you explored all the possible values of this dimension. Now you can move on to the next dimension. Okay, so that's what we will be doing in the project. All right, so now we mark the first one as done. I'm indicating that with the green lettering here. That is done. So now you move to the next one. So here the next one is the scheduling, right? For scheduling, again, it's just going to be like 2 settings in this case. Okay, so it's going to be either in order or out of order. So it's like whether to enable out of order or not. Okay, so you will explore both of these parameter settings, and you will have execution time for both of them. And then you will decide on one of them as the best setting based on the lowest execution time. And then you will mark this dimension also as done. And then you move to the next one. All right. So how many possible values are there for each dimension? That is one question that you might want to ask yourself when you are doing such kind of a thing. So because we saw that for the width, we had 4 possible values. Now coming to scheduling, we have only 2 possible values. And when you go to L1 block, it's going to have like, I think like 4 or 5 possible values. So that information is given in the dimension cardinality array. That's also a part of our code that we will go through in some time. So the dimension cardinality array will tell you exactly how many possible values are there for each dimension. All right. Now, let's look at something in the middle here. So we have already explored like 8 dimensions already, and we have the best settings set for each of them. And now we have come to the 9th dimension, and we are going to explore the 9th dimension. So what are the things that we should consider when we are in such a situation? This is going to be a generic situation for all your code. So that's why I'm explaining this. So while exploring a new dimension, make sure that you assign the already explored dimensions to their best settings. So 2 is the best setting that you found for width. 0, which means in order, is the setting that you selected for the issue. The parameter scheduling, right? So for scheduling, you selected in order. So all those best settings you have to keep track of, so that whenever you are exploring a new dimension, the older dimensions will be set to the best settings that you have seen so far. All right. And then the currently explored dimension will be assigned a value which is not explored yet. All right. So so that means, I mean, you don't want to repeat any of the runs with the already explored value, right? Because you know the performance number for that dimension with that value already. So there is no point in repeating it again. So you always stick to something which you don't know and explore that dimension value. right? So all the and now so we decide we have set this value as a new unexplored value. Now all the dimensions towards the right of the currently explored dimensions would be unexplored dimensions, right? Because we haven't reached them yet. We are in the process of exploring dimensions one by one, right? So all the unexplored dimensions are set to the baseline value. Again, we started off with the baseline value, and we are exploring one at a time from left to right in this example. And when all the dimensions that are unexplored will be set to the baseline value. All right. So there is going to be a difference in the sequence in which you have to explore. Right now, I'm telling you that you just do a left to right sequence of exploration, but in actuality, you need to do exploration based on your Penn State ID, which I will explain in a couple of minutes. All right. Okay, so let's go to the next setting. All right. So another thing that I want to add is that I had already told you, like the first 15 of the settings are independent parameters. Basically, it means that you can independently assign values to them. However, the last three, which are latency values for the cache, are dependent parameters. So the value for these dependent parameters depends on the value that assigned to certain cache parameters uh, in the cache parameters in the previous settings. All right, so the ones that I have selected here, they are cache settings that governs or determines the latencies for the last three settings. So based on these values, you need to recalculate what should be the latency settings. All right, so information on how to do that, how to use these values to generate these values, that is also given in your project guide. So you need to go through that to understand exactly what needs to be done. um, that information is there in section 8.3 of the project guide, so you can go and refer to that information. All right, so the last three are dependent dimensions, and you need to um, write code to find out the values that can be set to these values based on the values that you assigned for this. So you have to think about it like this. So in each design point exploration, so whenever you are going to run, whenever you changed anything related to a cache setting, you need to recalculate the cache latencies. All right. So, and then only you should run the simple scalar simulator. So keep that in mind. Now, yeah, so another thing to watch out for, let's say we are exploring the L1 block size, and let's say it has possible values of 8, 16, 32, and 64. All right. So this is a currently exploring dimension. All right. So if your baseline had a value of 1 in it, that means that when you were exploring the previous dimension's last value or previous dimension's best value, you would have already explored the value for this one as well, right? Because you had set this value to 1 from your baseline, right? So you need not explore the value of 1 again. 1 basically means 16, right? The value of 16. So you need not explore the value of 1 again, since it was a part of the baseline. But if you change the value of this, so if you want to switch to something else, you need to change the value here. But otherwise, you have already explored this value. So can you skip rerunning this baseline value again when you are exploring this new dimension? If so, what you need to do, you need to think about that when you write your code. All right, so these are some stuff to improve the performance, but yeah, you have to understand, figure out how to do that in your code. All right, so now connecting to the server, that's I will show you, I will walk you through how to connect to the server, and if you haven't started your project, that will be helpful. All right. Okay, so I am using a Linux machine, so I'll be showing you there on like how to connect to the server. But basically what you can do is you can go to the project guide here, and you have a link here that you can open to understand what is needed to be done. So first thing is that you are going to run all your code on the lab machines, and to access the lab machines from your home, you need to have the Penn State VPN installed on your machine. So basically you should be looking at this one, so PSU VPN, and you have separate downloads for each of the operating systems that you may be using. I am using this one, so I have installed this particular one here. And so if you are working from the university network, you don't need to do this. But if you are working from your home, you need to do that, and you need to connect to the university server. So this is how it is done in the Linux. So you can just type this thing, and it may take some time, but yeah, let's see how it happens. Yeah, but if you're working from the university, then you don't need to do this step. You can skip this step. All right. So now it says it's connected. So I'm connected to the university network, and now I can SSH into the university lab computer science lab machines by typing up this command. All right. So this is the command that you need to type. So basically from here all the way to the end. So, right. So this is the command that you need to enter. You can have different values for this integer here. I have 0, 1. You can have up to like from up to 38 as a value. And this is my username. So probably you need to change that and enter your username there. And I enter the password, and it's going to do that duo thing. And yeah, that's it. So I'm logged in right now. All right, so let me, all right, so I will start fresh from here. Like I will remove all the files, and I'll show you what exactly is to be. So okay, let's say you created a new project folder here with the name project one, and you want to get the project files to this folder from your machine, right? So how to do that? Let's say, okay, I'm opening a new window here. So on the right, I have the terminal, which is on my laptop, and this one is on the server machine. Okay, so I have the project files in a folder like this here. So these are our yeah, so these are the project files, right? So basically to get this file into this folder, so right now this folder doesn't have anything. So what you can do is you can use a command like scp space your project files. So I need to copy all of these files to the server. So basically I can just type in a wildcard star, then space, I need to enter my server address. So that is going to be your exactly like your SSH address. Let me enter that. csc.psu.edu followed by a colon. Now I need to tell the scp command where I should copy these files to the destination on the server, right? So back here, I can get the destination by typing pwd present working directory, and I can just copy this path, and I will paste it here. Okay, so I'm telling that copy all the files in this directory from my PC to the server machine and at this location. So that's what I'm doing here. It will again ask for the duo authentication. So yeah, have your phone with you. And yeah, now it's all copied. So basically now I can close this tab, right? Because we are going to work on the server machine. And yeah, remember that you all have to work on the server machine because the simple scalar is installed on the server machine, and there is no way. I don't know if you can get it set up on your PC, but then I wouldn't go in that direction because the project code is going to get evaluated on the server machine. Even if it works on your PC, it may not work on the server machine. And if that's the case, we won't be able to evaluate your code. All right. So make sure that you do all this work on the server itself. All right. So yeah. So basically now we have the project files in the server machine. Yeah. Okay. So the first thing to do is that if you see this file, this is an executable shell script. All right. So in order for it to execute, you need to give it execution permission. And how you do that is by typing out this command, chmod 777, then the file name. So now if you do ls, you may or may not see a color change. All right. So if you do ll, it's going to tell you that read, write, execute permissions are available for this project, this file. All right. So we need that. Otherwise, you may run into some errors when you run your code. All right. Because yeah, it cannot run. So basically do that first. And then what to do is that, okay, how to build the project? You can just do make, and it should be able to build the project. All right, so once you do the make, it will generate a DSE. So again, DSE is an executable. You should be able to run it. Yeah, so basically these are the things that you should be looking at first. And probably if you are using Vim as a text editor, you can also make use of this command here. Basically generates the tags for your project, but it's unrelated and you can skip that step. You don't need to do that. All right. So, but it will help you to navigate your code in Vim. So that's why I was doing that. Anyway, so let's get started with the code walkthrough. So I just explained to you how to connect to the server, how to transfer your files to the server. And yeah, so now let's go through how to edit files, and I mean, what's the meaning of the different files and all that stuff. Okay, all right. So let's start with run project suite.sh, because that is one important file. Basically, all the files are important. I'm just going with this because it's very similar to, it's very revealing of this particular setup that we have. Like it takes a lot of inputs along with workload, and then it configures a simple scalar, and then it'll generate the output files. All right, so we are going to see how that is done in this code. All right, all this stuff is already done for you. You don't have to do any coding to get it done. I'm just explaining what exactly is happening in different files. All right, so this is your run project suite.sh. You can read that over here. And let me go to the top. All right, so this is the first line of the code, right? So you can see 5 different benchmarks. Okay, these are the benchmarks, or rather, these are the application workloads that you are giving to the simple scalar. So the workloads, there are 5 of them. That's what is listed here. All right. After that line, from line 13 onwards, you will see the list of design space parameters and their possible values. Right. So width is a design space parameter, which comes in here, right? It's a core configuration. So now I'm going to show all the design parameters. All right. So width can have 4 different values, 1, 2, 4, and 8. Okay. Scheduling can have 2 different values. It's issue in order or issue in order false. Issue in order true or issue in order false. 2 different values. Similarly, we have cache parameters after that, where all these are set. All right. The L1 block, DL1 set, DL1 associate. So what all of each of this mean, you can try to understand it on your own. Basically, what you should be looking at. So L1 block is something that is common to both data L1 and instruction L1. All right. So DL1 means data cache at level 1. All right. Data instruction cache at level 1 is represented with IL1 starting. UL2 means unified cache at level 2. All right. So basically, you should understand that there is an instruction cache, there is a data cache, and both of them are connected directly to the pipeline, because whenever the memory access happens, the memory access is going to come directly to the instruction cache, and the instruction memory accesses will come directly to instruction cache, and data memory accesses will come directly to data cache. But if it is, if the data requested is not available in the level 1 caches, the request will go to a unified level 2 cache that is shared between both instruction cache and data cache. Okay, so that's the architecture that we are looking at. And these are the settings that are going to configure the cache parameters. All right. So now after that, we have the floating point width, the branch settings, the return address stack, branch target buffer, and then we have set of latency parameters. All right. So these are the design space parameters. So this is the first set of workload inputs to the simple scalar. Then we have a set of parameters to the simple input parameters to the simple scalar. After that, following that, we have the call. So basically the call to the simple scalar simulator and generation of the output. That's what we are going to do. So this input is given to the simple scalar simulator. So this path, the path that I'm going to highlight right now, is going to represent is the execution path of the simple scalar simulator. So this path has the executable that is the simple scalar simulator. So I told it the simulator is a code and there is an executable for that. So that's what is happening here. And basically this for loop is going to call this simulator for each of the benchmarks. Basically we have 5 benchmarks, right? So for each of the benchmark, we are going to call this simulator, and we are going to use the settings that you configure and run the simple scalar simulator, and then it will generate an output in this particular folder. So basically this is the output folder where the output is generated. All right, so that's what is happening. So basically run for each set of, so basically whenever you execute this file, you will pass one possible value for each of these parameters, only one possible value per run, and those values are assigned to the parameters here, and you will this file will call the simple scalar simulator for each of the benchmarks, and it will generate the output in this folder. So for each benchmark, there will be an output in this raw project output data folder. And once all the 5 benchmarks are done, basically you would have generated 5 different output files for each for one run, right? So once all of that is done, you will this code will also generate a empty file starting with done, and I believe ending with done, to indicate that this set of values for design parameters is explored. So this is an indication that this set of values have already been explored. So this we will look at why this is needed later. It's just to skip the design points that are already explored. So if you keep giving the same set of parameter values again and again, there is no point in running this code again and again, right? Because it's already explored. So the presence of this file will indicate that this set of values are already explored, and it will just keep the execution. So that is one reason why if you are running the code and you may see that the same configuration is not running at all, the output file remains the same, it's not changing with your code changes, one thing to do is to delete the file done files in the project output data folder. Then it can run again, because if it is available already, then the code will skip the execution of that particular setting. All right, so that is the explanation for run project suite.sh. Now let's go to other interesting files like 431 project.cpp. So this is the main C file or CPP file that you will be using. So this contains the main function. So if you are aware, every C CPP program should have one main function, and that function is here. So all the execution will start from here. All right. So there's a lot of details here. You may want to go through it, but if you don't, that's all right too. This just some housekeeping that you need to do before you start executing. So basically, if you look here, it's generating some directories. So if you have already run the project, you would have noticed that whenever you execute a code, these kind of directories are generated to store outputs. All right, so those are all done by the C code. All right, so that is what is done here. I'm not going to go into the details of that, but if you want to, you can. Yeah, so because understanding that will give you and a better, you will be more flexible to modify the code if you understand what exactly is going on here. But if you don't, that's all right too. Okay, so first, what the code does is that it's going to test the baseline. All right, so if you remember in the presentation, I had told that initially we have a blank slate and we for the configuration settings, and we populate it with the baseline value, right? So that's what is happening here. So basically we are going to start with our baseline settings. And what is our baseline settings? It is given um, in the header file. So let's go to that header file. So this is the header file. And if you look at line 5 here, you can see that it says global baseline. All right, so this is the baseline setting for all the parameters that we are going to see. So the parameter names are also given here. See, width, scheduling, all that stuff is here. And these are the default values that you are going to start with. So all of you are going to start with these default values. All right, and try to explore these values. All right, so in the project main, we are going to start with the baseline. And so you are going to run the experiment in the sense that you are going to call so initially the main, this is all done on its own. Okay, you don't have to modify anything in the 431 project.cpp, but I'm explaining all this stuff to you because it will help you understand what exactly you are doing, and then only you will really understand what is the modification that you need to do. All right, so this run experiment function is actually going to call the file run project suite.sh with the baseline value as a setting. All right, so let's look at the baseline value. So it says 0005, right? So this array, this 18 array is passed to run project suite.sh by this run experiment function. All right, so what happens is that after it gets called, uh, if the baseline had a value of 0005, what that means is that bit will be set to the 0th index, which is 1. Scheduling will be set to 0th index, which is in order. Then L1 block size will be set to 8, because again, L1 block had a value of 0 in the baseline configuration, right? And then 5 is the value given to DL1 set, which basically means it will be assigned to a value of, I believe, 3, 4, 5, 1024, right? So DL1 set will have a value of 1024 and so on and so forth. So that's the value being passed from here in the global baseline. And so basically the code will configure all these parameters, and then it will run the 5 different benchmark with this set of values, and it will generate the output, and it will also create the done file, so that to let us know that this configuration is already done. So if you try to run it again, it's not going to do that because it's not needed, right? Because it's already done. All right, so that's what is happening in the run experiments. So once you do that, your results are generated. Now populate in this means that you are going to read into the project files that were generated and extract the information that is needed, and then try to understand or extract the values that you actually want from those values and calculate the performance metric. So baseline, we calculate the geometric mean for EDP and the geometric mean execution time for the 5 different applications, right? So you might want to think about why we use geometric mean for this calculation, but yeah, that's what we are doing right now. So we had 5 workloads that were run, and so we got 5 different numbers. So we take the geometric mean for all those 5 different numbers, and we say that that is our EDP value. And similarly, we do the same thing for execution time, and we say that is our execution time mean. All right, so since this was the baseline that we just ran, we will assign the current execution time and EDP as the best EDP and best time that we have seen so far. All right, so this is the best numbers that we have got so far. We do this because we can compare against the future numbers that we get, and we can say that, okay, is my new setting doing any better than the baseline or not? If we are doing any better than the baseline, then we will use that new better values as the best values that we have seen so far, and then we keep going in the direction which points towards like improving the performance or improving the energy consumption. Okay, so that's what is happening here. So basically we get this geometric means and we assign them as the best value that we have seen so far. All right, now after once the baseline run is done, then we have a loop here. Okay, so this is what we were talking about previously. You have 1,000 iterations to find out the best setting for different parameters. All right, so you start from baseline values, and then you can change one parameter setting at a time, and you need to decide whether to keep that changed value or not, depending on if you're making improvements, and then you proceed forward. So 1,000 iteration means if you start with the issue width, you have 4 different values for issue width, right? And then you try one at a time, and after 4 runs, you would have got the execution time or the energy for all the 4 runs. You compare among that and you decide which is the best value that you have got so far, and you keep that best value for this issue width. Then you move on to the next setting, then you compare different values for that, and so on and so forth. So that is what is that is what should be happening in this 1,000 iteration loop. All right, so so let's now look at what exactly is happening here. Okay, so when you enter this for loop for the first time, your baseline is your best configuration so far. That's your, in fact, that's your only configuration, but we consider that as the best configuration that we have seen so far. And then it's your job to propose a new configuration. All right, a new configuration for the parameters, and this is one of the functions that you need to modify. All right, so imagine, so you will write a code to identify what should be the next set of values for the configuration inside this function. All right, but assume that you have already done that for now. So that we can look at the rest of the code. We will go into the details of this function in a bit, but let's just, for the time being, let's assume that this is already done. That means that the next configuration will have, next conf will be the next proposed configuration, and the simple scalar is going to run on this next configuration to find out if it is any better than the previous configuration that it has seen so far. All right, so again, the code is just going to be very similar to what we did in the baseline run. So first you do the run experiment with the next conf, right? And then you populate basically means collect the results that were generated from the run experiment, and then you calculate the geometric mean, EDP, and execution time, right? So that some calculation is involved in that. So that those are the proposed geometric EDP and time. Proposed in the sense that next conf is the proposed next configuration, and for this proposed next configuration, these are the proposed geometric EDP and geometric time. All right, now we compare this proposed time and energy with the best time and energy that we have seen so far. So if it is your first iteration, you are going to compare against the baseline EDP and time. But if you are well into the iteration loop, you may have a different value here. But anyways, we are going to compare it with the best value that we have seen so far. And if it is any better, if the proposed one is any better, then we are going to update the next conf as the best time configuration, or so or the best EDP configuration, and also keep track of the best time and best EDP that we have seen so far. So this code is needed to keep track of what is the best that we have seen so far. All right, so that's the purpose of this. Also, there is some printouts. So this you can see on the screen. When you run the code, you can see, you'll be able to see some stuff being printed. So that and all is coming from here. And yeah, so that's it. So then the next conf is made as the current configuration, because you already ran the next conf now. And so it is made as current configuration, and then it is passed on in the next iteration as the current configuration into the proposal function. All right. So that's what is happening there. And finally, when you come out of that iteration loop, you would have already found out the best EDP configuration as well as the best time configuration. And to populate that into the file for a later comparison, we have some code written here. It will dump the best EDP, best time configuration stuff onto some file so that you can read it later. Yeah, so that's it. So that's the code pretty much. And now you would be wondering what is to be done in the generate next configuration proposal, because that's where all this stuff happens, right? Also, you should understand that most of the things that I explained in this presentation is already done for you, and your task is just to uh, figure out how to do this, how to try out different values for different settings, how to move forward and try out value for different setting. Then you will also have you should also decide on like what setting value should I keep, which is the best that I have seen so far. Then before, so that when I move forward to the next dimension, I still maintain the best setting that I found for the previous dimension. All this code you need to write, but all the other code which is related to like this stuff, right, reading from the configuration and passing into the simple scalar or workload configuration, or how to read the output of the simple scalar, how to make sense out of it, how to compare the different outputs across different design points, all of that is taken care of for you by this baseline code or this the framework. Basically, you are only going to modify things inside this file function. All right, so let's look at this function. So yeah, so this is the file where you have the generate next configuration proposal that's in your code here .cpp. All right, so let me go to the top. You can just open it on your own, but yeah, this is what I was talking about. So all your modification is probably going to be in this, I mean, definitely going to be in this file. I would highly recommend that you don't modify anything in any other file actually, because that will create a lot of issues later. So restrict all your code to this file here, your code here .cpp. All right. So now, yeah. So now let's get started. So let's go to the top. Okay. So before that, I need to make sure one more thing. So I told you about a baseline configuration that I have shown you here, and I was explaining everything with a view that I'm going to start from here first, and then I go forward one at a time until I reach the end. But that is not true. There is something, uh, the sequence in which that you need to explore different dimensions is going to be different. Okay, so let's look at that. So if you go to the top of your code here .cpp, you will see something like define PSU ID sum. So this is your pen state ID basically. So a maximum 2 people can group together to form a team, right? So that's why there are like 2 pen state IDs here. But if you're only a one student doing the project, then you can set this entire thing to 0 so that only your pen state ID is considered when this calculation is done. All right. So why do we have your pen state ID in this project? That's because, okay, let's go to the project guide now. So this is a project guide. And okay, so if you go here on page 3, I believe, it is explained what sequence to go through in exploring the different dimensions. Okay, so if you are a 2-person team, then you add your pen state IDs and then you take the modulus operation with 24, value of 24. Why do we do all this? To understand that, you need to go to table 1. All right, so this is table 1, and you can see a set of 24 values in this table. All right, so after that calculation of pen state ID sum modulus 24, if you got a value like 10, all right, if your remainder is 10, That means that you need to explore the dimensions in this order, like cache, floating point unit, branch predictor, and then core. All right. If you follow some other sequence, that means that you did not follow the guidelines of the project and you may not get credit at all. All right. So be careful about this one. Find out the sequence that you should be doing and stick to that. All right. So different student teams will be doing different sequences and their results are going to be different because their starting point is different. So you should understand what your sequence should be. So if it is 10, stick to cache, FPU, branch predictor, and then core. And what this means is that, okay, now let's go back to the project header file. So if you look at all the dimensions, all the different dimension names here, you can see that a set of values, a set of dimensions are specific to cache, right? So these are going to be specific to cache. And all right, so basically what it means is that you need to explore L1 block first. So if you got a value of 10 or even 6, 7, 8, 9, 10, 11, you will first start with cache settings. That means that you will start exploring at L1 block, then DL1 sets. Basically, you will start changing values here, then here, and keep going forward like this until you have finished exploring all the cache dimensions. Then after that is done, you need to go to floating point unit. All right, so that what that means is that you have some floating point settings here, right? So you need to go and explore that. Once that is done, you have to go to branch predictor settings. So branch settings are here. So that is done. Then you go to core. Core settings are width and scheduling. So you go explore that. But one thing is that, yeah, so basically this code here is helping you to identify your sequence number or the sequence. So if you want to, you can actually do the modulus on this thing after updating this pen state IDs and then print it out and see what the remainder is. And then based on that, you can select the sequence that you need to follow. All right. So you can code that up. You can hard code it if you want, but yeah, it's up to you. But anyways, that's what is here. So now let's go through some of the global parameters, global variables that are used in this file. So currently exploring dimension has an initial value of 0. What that means is that this points to the dimension that is being explored right now. All right, so let's go to the project overview. So I was talking to you about this scenario where you explored all this stuff and now you're going to explore this one. So this is the currently explored dimension, and this variable currently exploring dimension should point to this location. This location, the sense the offset of this location. So basically that's going to be like 9. Sorry, if it is starting from 0, then it's going to be 8, right? So currently exploring dimension will be 8. And so that's what this means. So whenever you are done exploring a dimension, like in this step, in this case, you are done exploring a dimension when you identify that 4 gives you the best value, right? So till then, when you were exploring this dimension, this variable had a value of 0. Okay, so once you identified that 4 is the best setting, then you need to move on to the next dimension. So you need to increment the currently exploring dimensions value as well. So that variable will become 1 when you start exploring this. Once you identify the best for that, then you move on, then you increment that again. So that's the meaning of currently exploring dimension. Then, and there is another Boolean called current dimension is done or not. Okay. Why we need this is because, again, going back here, when you start currently exploring dimension will have a value of 0, and currently the second Boolean current dimension done will have a value of false. All right, and then you keep exploring each of this stuff, and once you identify that this is going to happen in different iterations of the for loop. So we saw a for loop with 1,000 iterations, right? So in the 0th iteration, you will explore this one, first iteration, second iteration, third iteration. So when you enter the 4th iteration, you had already explored all of this stuff. So you don't have to continue the fourth iteration also in the same currently exploring dimension. So you would have already incremented the currently exploring dimension here, and then you should um, use this boolean to signal that this dimension is already done, so you can move on. And again, you have to make it false when you are exploring that dimension. All right, I hope that makes sense. But this is depending on the your implementation, you can modify it. So basically what I would recommend is that this will be set to 0, this will be set to false when you enter a new dimension, and then that boolean will remain false until you have iterated through all the dimensions, and also you have identified the best settings so far. So once you identify the best setting, then you will set that boolean to true. That means the current dimension is done, and then you can go ahead and increment the currently exploring dimension to the next dimension and go ahead from there. So this is like a signaling mechanism that we have here. And then lastly, there's another boolean called is DSE complete. This basically is used when all the dimensions are explored, all of them are done. Then if you want to just terminate, then you will just set this variable to true, and you can exit the for loop, the 100,000 iteration for loop, and end your code. All right. So that's the variables here. So now let's look at what is the generate next configuration proposal. All right, so this is the main function that we'll be working with. And let's go into the details of that. So some of the parameters that will be helpful for you when you are going to do modifications to this project file is the cardinality. So I talked to you about cardinality somewhere here. But anyway, so let's go back to the header file. You will see the dimension cardinality is available here. So what that means is that, so for width, the cardinality value is 4. That means width has 4 possible values. So you can only explore up to 4 different values in width. So if you set it to, if you increment the, if you go and explore some value like 5, it's going to be an out of bound error, right? So we want to avoid that. That's why this cardinality is helpful to us, because if you look at this project suite.sh on the top, you see that width has 4 possible values. Scheduling has 2 possible values. L1 block has 4 possible values. So 4, 2, 4, right? That's what we have here, 4, 2, 4. It's just telling the maximum number of values that you can try out for each of these dimensions. All right. So that's handy when you write the code. Another thing is global baseline that you already looked at. These are the basic default setting for different parameters when you start out your exploration. Okay, then the number of dimensions will give you a number value 18, indicating that there are 18 dimensions here. You may use it, I don't know, or you may hard code it, but yeah, it's there. Then we have number of dims which are dependent. It's already hard coded for you. It is given as 3, and those 3 are the latency, which are the last 3 parameters in the dimension names. So just to indicate that value is 3, we have this here. And then global scene configuration. So that is something different. I believe that is a map data structure. Yeah, I think so. Yeah, okay. So that is like a map. Basically, what we do is whenever we have explored. So this is one explored configuration. After the right before entering the for loop, we will explore the baseline. So now baseline is a already seen configuration. So you will push that into the already seen configuration so that you know what you have explored so far. So when you go to the next one and explore, the exploration is complete, you will push that into this again. So that is what is here. You may use it for your coding purposes, right? So, okay, so what's happening in this function right now? Right now, this function is going to take the current configuration, which was passed in from the main.c main file, right? And then okay, so first thing to do is validate that this configuration is valid or not. So that's something happening here, validate configuration. All right. Okay, so what that means is that when you pass some configuration into this function, you cannot just blindly pass it on to the simple scalar simulator, because if these are 18 values, right? What if you pass a 19 value string to the simulator? Then the simulator is not going to work properly, right? So you need to make sure that the configuration setting that is passed to the simulator is of correct length. Also, the individual values of each of these parameters is valid, because as I told you, the cardinality for width is 4. And if you pass a value of 4 here, that's going to give a out of bound error, right? Because only 4 values are possible, and this is an index value. Sorry, this is an index value. And if you pass 4, it means that and with a cardinality of 5 is needed to have a fourth value here, right? 0, 1, 2, 3, 4, 5, 4. So basically a value of 4 is invalid. So you need to take care of all that stuff, right? So that is already done. Most of that is done already for you. That you can see by looking here. So this is another function that you need to modify to validate the configuration. Okay, so that is right above this generate next configuration proposal in the same file, your code here .cpp. So apart from this, you may also want to validate your configuration based on some criteria that is mentioned in the project report. All right, so let me just open that quickly. Yeah, it's here. All right, so it's in 8.3, I believe. Yeah, so validation constraints are mentioned here, okay? So you need to make sure that all these constraints are met. So you may want to take care of that as well in your validation function, validate configuration function. But understand that the main function calls the generate next configuration proposal. Inside that, validate configuration is called, and that function is defined, should be defined here. All right. So once you know that the configuration is valid, and also it's not a part of the global configuration that you have seen so far. So this is a loop that will exit immediately if any of these constraints are not met. Okay. So basically that is the purpose of this thing here. Sorry. Okay. Yeah, so that's the purpose of this checks here. So it will just validate the configuration, and also it will check it against all the configuration that you have tried out so far. All right. And after that, then the next thing for us to do is, so this piece of code, what it does is it is extracting the best configuration that it has seen so far into the best config temporary variable. All right, so this is the best execution time configuration that we have seen so far. This is the best EDP configuration that we have seen so far. And since we are going to run only performance or energy optimization at a time, we can copy that safely into the same variable name here. Okay, that's why we are doing this. So if we are optimizing for execution time, then best config will have the best exec configuration that we have seen so far. Otherwise, it will have the best EDP configuration. All right. So once we have that, you can assume that once the code reaches this point, you can assume that the best config has the best config corresponding to the optimization that we are doing, whether it is performance or energy. All right. So now we have 3 pieces of code here. You can say there is one filling piece here, there is one updating piece here, and then there is one and then there is one filling piece here again. So what this means is, I will explain again with that diagram here. So let's consider this scenario, right? So you had already tried out some configurations. You have already tried out some dimensions. Now you are going to explore one dimension, and you have many unexplored dimensions also. This is a scenario that we are looking at here. So first, in dimension 0 till the currently exploring dimension. All right, what that means, from 0 till currently exploring dimension. Here, this is the currently exploring dimension, and this is the already explored dimension. So from 0 till the currently exploring dimension. So from here all the way till here, what you want to do to the configuration proposal is that you just want to copy that from the best configuration. All right. So that's what is that. This SS is a temporary string, and you are trying to uh, uh, propose a new configuration by updating this temporary string. Okay, that's what we are going to do. How do we do that? So first SS is empty, but once this loop completes, what happens is it would have filled up the best settings seen from here till here. All right, so of this entire array, we have the best settings for these many fields. That's what is happening here. All right, after that, you need to update the currently exploring dimension with the next value to be explored. All right. So this function is handy because it extracts the configuration parameter from the next configuration. What that means, okay, let me explain that. So here, if you look at the baseline configuration, it's a string, right? It's in inverted commas, and it's a string, and each of this is a character. All right. So if you want to get what value it is at this point, you cannot just read a string and get the value in C. All right. For that, you need to actually split the string into individual array, an array of characters. Okay. So first procedure is it will split it into characters and then convert the index from character to integer so that you get the value of 5 as an integer. Okay, it's a tedious process, but it is already done for you in this code. Okay, so this extract configuration param is doing that exactly. So if you already have a configuration like this baseline string, and if you want to extract a particular value from that string, I mean extract the value of a certain field from that string. So I can say this is my configuration string, and I want to know, I want to get the integer value of the parameter at the position 3. All right, so 3 corresponds to 5 right here. So at the position 3, what is the value? I want that in integer. All right, that's my requirement. Then what you do is you pass this string and also your index number into this function. All right, and that will return an integer value back. Okay, so if I had passed this string and an integer 3, what it does is it will extract this character, which is at the third index in this string, and then convert it into integer and then return that value back to me. All right, and this function will return that value back to me. And then what I'm doing here, I am adding a +1 here to indicate that I am not interested in the current value of this parameter, but I want to explore the next value. All right. You want to, you want to rewrite all this code. I'm just explaining what is happening here so that you can actually modify this code for your sequence. Okay. So first, you filled up the values from left to right. Then you updated the current dimension with the next value that you want to explore. All right, that's what is happened here. And so since you're blindly incrementing the value here, you need to do some checks, because if I increment a value of 3 here to 4, it's going to become invalid, right? Because it can only have up to a value of 4. So integers 0, 1, 2, and 3 are only valid for this field. If I just increment it to 4, it's going to become invalid. So that check is done here, okay? So you want to rewrite all this code for your own sequence and your own pattern in which you are going to explore, but I'm just explaining it right now. Okay, so what happened here is that you want to insert a space. So it's just trying to create this sequence. So imagine this is the parameter that you are exploring. So you filled up till here, and then you inserted this new value of say 6, and then you inserted a space. That's what is happening here in this line. Then in the remaining independent parameters, here it is filling with 0, which is wrong, right? Because as I discussed, you want to fill them with the baseline dimension value. So baseline dimension is this value. You can get that from this field here. So if you are currently exploring this field, you want to fill the rest of them with these values, exactly these values, right? So that is what is happening in here. Okay, but you see that the last three parameters are not updated here. So these three parameters are not updated in this for loop. Why? Because these are the dependent parameters and you want to calculate it on your own, right? So rest of them are updated with 0 here, but you want to change that into baseline code, baseline configuration, right? And yeah, so that's what happened here. And then, okay, so this is just converting this string into a, sorry, it's an array of strings and into a string here. Okay, all right, so it's not that relevant. And then you are going to pass this string into the generate cache latency params function. This is a new function and which you want to modify basically, right? So let's go to that function. That function is right in this file itself. So if I just do star, so this is the same file at line 42, you will have that function, right? Right now it is just doing nothing. It just returns a 111 as value. So what basically happens is that when you call this function, it is going to return 111 into the SS. What that means, you already have updated all the values of SS from this dimension until here, and that function will return 111. So it is actually configuring the last three parameters, and that's what is happening here. And how to update that parameter? Okay, so for that, you need to refer to the project guide again. All right, so project guide is in this here. So the latencies are mentioned here in the validation constraint. I believe that's the only place where it is mentioned. You can go through the file and figure out where else it is mentioned, but I believe this is the case. So basically you need to update these two functions using the numbers given here. All right. So depending on different cache settings as described in this document, you have to give values here. So possible values, what are the possible values for latency? Let's look at that. The possible values for latency are given in here. If you go down, you can see that the latency can have these values, right? 1 to 10 and 5 to 14 for the unified cache. All right, so these are the possible values and you need to assign them here after checking with the validation constraints in the project guide. All right, so you have generated your cache latency parameters and you have added that also into SS. So what is happening here? First you copied all the best configurations, then you updated the current configuration with the new setting that is already not explored, and then you push that also into the SS. And now after that you update it. So this piece you need to, I mean, all these settings you need to, I mean, all this code you need to rewrite. But I'm specifically saying here that 0 is not what you want in the unexplored dimension. You want to set that to the baseline. So you fill that in. After that, you filled in the latencies as well. So now you have a complete string, right? You build up a new string with new set of values in this format, but with different values, right? Hopefully different values, because that it cannot be same as a baseline value, right? Because you are proposing something new. So once that is done, you have your next configuration ready. All right. So basically that's it. So then you pass this next configuration back into the um, back into the main function, where it will run the experiment using the simple scalar simulator and generate the output. All right, so that's what is happening. So once you are done with the dimension, so let's see what is happening here. The current dim done, right? So that right now it is set to true when so right now what happens in the code is that it will explore all the different dimensions, and once all of them are exhausted, all of them are done, then it is setting it to true so that it can move on to the next dimension. So that moving on to the next dimension is done here. We increment the currently explored dimension by 1, and current dimension done is set to false, so that because the next dimension is not done yet, so you will do it to set it done when that is also explored. But the key thing to understand here is that this sequence is completely wrong. This is the dumb way of doing this exploration. What you want to do is you want to look at this code, sorry, look at this table here, identify your sequence and follow that sequence. All right. So the sequence that I showed you right now, it's just going to go through the from left to right in a sequence, and all of them are explored one at a time and then move on to the next and so on and so forth, while setting the rest of the parameters to 0. So when you are exploring this, it is going to set all this value to 0, which is wrong, which is not what you want in your submission. You want the baseline values to be here. Also, you want to move in a sequence that is decided by this particular table. So keep that in mind. Yeah, so basically that's it. So that is the exploration. And there are 3 different functions that you want to edit. First one will be your next configuration proposal, which will have a lot of changes. As I explained right now, I have explained what is there right now, and you would have, I hopefully you would have understood exactly this. There is a lot of changes that needs to be done because the sequencing is all wrong. You need to take care of different other corner cases, which I may not be even aware right now, because once you start coding, you will understand all the intricacies of what changes that are needed to be done. And in support, to do this thing, to do this function, you have to implement this function completely, you need 2 supporting functions. First one is a validate configuration function, which will validate your settings. And the next one is your generate cache latency parameters that will decide the dependent parameter values, which so both these functions you are going to write based on data given in the section 8.3 of this document. All right, so read this thoroughly and understand what is to be done and update this code and think about what is to be done in this next configuration proposal and do that. All right, so once that is done, I think I'm pretty much done here. So once you have the DSE, you can just like do performance and it should run. All right, so I'm going to terminate it here. I can terminate it just by holding Control C actually, C as in C, and okay, it's allowed. All right, so now it's done. If you do ls, you will see that you have these files, folders generated. And if you go to the raw here, you can see a lot of sim out files generated, and basically that has the output from the simulator. And you see there is a one done file correspond. So this is the baseline setting, right? So this means that the baseline run was completed. That's why the done file was generated for that. And yeah, that's what is happening here. And so again, if you look at, so here this sim out files has a starting number which indicates the benchmark number basically. So if I look at just these files that that has that value, let's see if this works out. Oh, sorry. All right, so it is listing 6 different files, right? So basically the first number indicates the benchmark number. So this is the 0th benchmark running, first benchmark, second, third, and fourth benchmark running for the baseline configuration. All right, so if you open one of them, let me open like this one. This means that I'm opening the benchmark 2 and I'm looking at the content of the simulator output. It's rather detailed if you look at it. All right, but mostly we are interested. So you can see that the number of instructions simulated is 1 million. The number of cycles taken for executing this code was what, 3 million something, 3.3 million, and so on and so forth. So a lot of information here. And so this done file is going to be empty because there is nothing there. Its presence just indicates that the baseline run was completed. All right. So since I terminated it before or any other run started, There is no done file for anything else, but you will see a lot of done files. So that is what is in the raw project output data. I believe that's it. In the log, you will have the execution times given, so you can go through that and try to understand what's going on. The sequence in which these numbers are given is given in the end of this document, so you can refer there. I believe see you can read through this FAQs to understand that. All right, so it became a rather long video, so I'll stop it here. If you have any questions, then you can go ahead and um, email us. But just one more thing before we leave, you need to understand the project report is also a requirement for this submission for this project. So the details for the project report is detailed here. All right, so you need to go through that and try to make your report like this, because there is point for each of these deliverables. So be mindful of that. All right. Thank you. If you have questions, please come to the TS sessions or email us. All right. Thank you. Have a nice day.